Hi everyone, my name is Nagaraju Kakati. I am working as assistant professor in Marri Laxman Reddy Institute of Technology and Management. Now I am going to explain about the decision tree learning hypothesis space search in machine learning subject. So how we are defining or represent the decision tree. So first the decision tree is classifies the instances by sorting them down the tree from the root to the leaf node. So here I have to classify my instances starting from the root to the leaf state. Okay, so what is the root and what is the leaf node? So here out of my all attributes I have to find out the highest gain attribute as my root node, and again I down to the leaf condition. So this is my leaf state. So down from root to the leaf node by the classification of instances. Yes, here in each node of in the tree specifies a test of some attributes of the instance. So simply each node that specifies the test of the some attribute of instance. What about the branch? Yes, that branch descending from that node corresponds to the one of the possible value for that attribute. Okay, so now instance is classified by starting at the root node of the tree and testing the attribute specified by this node, and then moving down the tree branch corresponds to the value of the attribute in the given example. Okay, so here we start at the root condition and again we are down to the leaf state through the branches. For this condition, each and every attribute is undergo by the sum test. Okay, so yes, some test is to be assigned on the attributes instance, and again for the branch condition it gives the possible value for that attribute. Okay, now for this diagram, okay, just I try to note down the decision tree representation. So how for initially we have to define these decision tree representation. So it's simply disjunction of the constraints on the attribute values of instances. How we are representing disjunction of conjunction of the constraints on the attribute values of instances. Okay, so decision tree is mainly used for the classification of the instances. Okay, these instances, yes, for each path from the root node to the leaf corresponds to the conjunction of the attribute test, and the tree itself to a disjunction for these conjunctions. So here it clearly tells us about the disjunction of conjunction of the constraints on the attribute values of instances. All my attribute instances are in the conjunction. Okay, and these are here a tree itself to a disjunction of these conjunctions. Okay, so for this condition, yes, outlook comes to the outlook equals to how we're representing outlook, sunny and humidity. So sunny and humidity both are, it is represented by the end condition. So both, and humidity, how it is humidity? Yes, humidity is normal, then only we can enjoy the play. Okay, so enjoy sport example. Previously we observed the same one also. Yeah, now second condition, outlook overcast and again equal. So outlook equals to overcast. Yes, game is to be enjoyed. And next third condition, yes, outlook and wind condition. Yes, outlook equals to rain and wind condition. Whenever wind is equals to weak, then only we can enjoy the sport. Okay, so this is the already I considered the some decision tree representation. For that decision tree, I can use these hypothesis representations based on these disjunction and conjunction of my attributes instances. Now we try to find out the hypothesis space for this decision tree learning. So for that, I just considered one example that consists of 14 days of the different weather conditions and play the tennis is my final condition. So how I have to find out the hypothesis for this by use of the decision tree learning. So for this condition, I just measured the two principles or two values. One is entropy and second one is gain or information gain. So these two values are used for the measurement of the hypothesis in decision tree learning. Yeah, first one, entropy for the entire data set. How many days I have? Yes, 14 days I considered. Out of 14 days, I have the positive conditions and negative conditions. Yes, positives are one, yes, three positive, 3, 4, 5, 6, 7, 8, and 9. So out of 14, yes, 9 are positives and remaining 5, 1, 2, 3, 4, and 5. So remaining 5 are negatives. So 9 are positive and 5 are negative. So yes, now I try to find the total entropy for my entire data set. Yes, out of 14 observations or 14 days, yes, 9 are positive, played, and 5 are no condition. So now I try to find out the probability for that condition. Yes, probability for S condition. Okay, play tennis. S equals to 9 by 14. That's that value. And again, probability for non-playing or simply P of no equals to how many negative conditions? 5 are there. So 5 by 14 I consider. So the entropy is equals to. So what is the formula for entropy? Summation minus Pi into log Pi base 2. So guys, here very careful ma. So this log is base 10, but I didn't use this base 10. I use the base 2. So how we are measured? Yes, simply log value by log of 2 we have to easily measured ma. So then only we can get the correct value. So here, yes, what is my formula? Summation minus Pi into log Pi base 2. Okay, so what is my Pi? Yes, P for P of S into log of P of S value base 2 again plus P of no into log of no base 2 and entire this is by the minus condition. What is P of S value? Yes, we have the 0.643 and again log of 0.640 base 2 and again P of no value 0.357 and log of. So final simplification, we got the value as 0.94. So this is my final entropy for my entire data set. So 14 training examples, entropy is this one. Yes, now I try to split the each attribute. So how many attributes I have here? Outlook, temperature, humidity, wind. Okay, so here I have the four attributes. Now I try to split the each and every attribute. That means that we have to measure the entropy and information gain for each attribute individually. Okay, so first attribute is outlook. Yes, now in that outlook condition, okay, so if you clearly observe, we have the three different instances. One is sunny, second one is forecast, and third one is rain. These three are the different instances in the outlook attribute. Okay, so now yes, here I have yes sunny, overcast, and rain. So how many sunnies I have in the database? Yes, sunnies are 1, 2, 3, 4, and 5 sunnies. 5 sunnies. And overcast is 1, 2, 3, and 4. Next, what about the rain? 1, 2, 3, 4, 5. 5 rain. Okay. So now, yes, 5 sunny, 5 rainy, and 4 overcast condition. Okay, now I considered the sunny condition. I have 5 sunny. Out of 5, how many positives and negatives are there? Okay, so from the data given data set or considered data set, out of 5 sunnies, yes, how many negatives? 1, 2, 3, 3. three negative examples are there. That means 3 no's, okay, and 2 S condition. So similarly, we try to identify the S and no conditions for the overcast and the rain condition. So by knowing these S and no conditions, we can easily identify their probability. That means P of S, we already know now for the previous kind. Yes, P of S and P of no. So after measuring these P of S and P of no, we try to find out the entropy. So what is the formula we used? Summation of minus Pi into log Pi base 2. Okay, so we use the S condition and no condition. So what is the probability for P of S? Yes, here S is 2 out of 5. So 2 by 5 I can use, and again log of 2 by 5 base 2 plus next one is 3 no's. So 3 by 5 into log of 3 by 5 base 2, and it is by the minus. So if you solve this one, yes, we can get the 0.971. Guys, are you get my point? So based on the or from the formula of entropy, yes, we can measure these individual values. What is the formula we used? Summation minus Pi into log Pi base 2. Okay, so here, yes, I have the S condition, P of S and no condition values. So similarly for overcast condition, yes, I have, how many values I have? Yes, 4S and 0 no condition. So now for P of S condition, so 4 by 4 into log of 4 by 4 base 2, okay, plus what about the no condition? 0 by 4 into log of 0 by 4 base 2, and again this one. So by 4 by 4 equals to minus 1 into log 1. What is log 1? Log 1 value equals to 0 plus again 0 into value 0. So log 1 value is 0. So finally we got the entropy as 0. Okay, now so log 1 again its value 0. 1 into 0 equals to, we got 0. 0 plus 0 is 0 value. So like that we can measure the entropy for rain also. Okay, so now I try to find out the average entropy for the outlook condition. In outlook attribute, I have the 3 different type of instances. Those are sunny, overcast and rain. I individually find out the entropies for these 3 instances. Now I try to find out the average entropy for the outlook attribute. So how could I measure this one? So how many sunnies I have? Out of 14, yes, 5 are the sunny conditions. So for that 5 by 14 into its entropy value. Okay, next. Second one is overcast. How many overcast is 4? So 4 by 14 into entropy value 0. And next rain condition, yes, 5 by 14 into entropy. So this is the procedure to measure the average entropy. Okay, next now we try to find out the information gain or simply gain. So what is the formula for this gain measurement? Yes, entropy minus, okay, so that particular values SV by S into entropy of SV. So that is nothing but the average entropy. Okay, so average entropy. So simply, yes, information gain is equals to, what is the total or the net data set entropy? 0.940 minus, what is the average entropy? Is 0.693. So finally we got gain for the outlook as 0.247. Similarly, we find out the, yes, gain for the second attribute, humidity. Okay, so now humidity condition, yes, coming to the data set, yes. Now we are moving on to the next attribute, yes, humidity value. Yes, humidity, if clearly observed, only two different instances are there. One is high, second one is normal. So now I try to find out the Yes, entropy for the high value and no normal condition, high and normal. So from the data given data set, high, how many highs? 1, 2, 3, 4, 5, 6, and 7. 7 high are there. So out of 14, remaining 7 are normal condition. Now we try to find out the for these high condition how many no and how many yes conditions are we can identify those. Okay, so yes, out of 7 condition, yes, 3 are yes and 4 are no. For normal condition, 6 are yes and 1 is no. Again, we identify the probability of S for these high condition, probability of no for these high condition, and again probability for S for the normal and probability of no for the normal. These values, after measuring these values, yes, we use the entropy formula and measure the entropies for high and normal condition. After measuring the entropies, yes, we find out the average entropy value. Average entropy value 7 by 14 into yes, high condition entropy, and again normal condition 7 by 14 into and again value. So 0.788. Next, gain or information gain. Gain or information gain. How we are getting? Yes, total entropy, entire data set entropy minus average entropy. So what is the value? 0.152. So second attribute is completed. And next, third one is wind. Yes, if you observe the data set, yes, wind condition. Yes, in wind, how many instances we have? Yes, weak, strong. Only two different instances are there. Again, we identify the yes, how many weeks are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 weeks are there. So remaining 6 are positive. Sorry, 6 are strong. This is weak and this one is strong. Okay, so coming to this condition, yes, 8 weak and 6 strong. Again, out of 8, how many S's and how many no's we have to identify, and for the strong condition, S and no's have to be identified. After getting S and no condition, we find out the probability for S and no condition. After getting probabilities, we try to find out the individual entropies. Okay, so now after getting these individual entropies, we find out the average entropy. Average entropy. Okay, so now average entropy, how many week we have? 8. How many total instances? 14. So 8 by 14 into this individual entropy value and 6 by 14 into S entropy value. So finally we got 0.893. Yes. Now gain equals to total or entire data set entropy minus average entropy. Yes, value equals to 0.048. Guys, here out of 4 attributes, I find out the 3 conditions. And next, similarly, yes, temperature also we can measure. For coming to the temperature, how many instances? Yes, hot is there, mild is there, and next to cool. 3 instances are there. Okay, so now we find out the hot, next to mild and cool condition. Yes, here yes condition and no conditions measured, and for S condition, P of S, next to for no condition, P of no. And again after measuring these entropies, entropy for the okay high condition, entropy for mild, and entropy for cool condition. After get that, average entropy, and finally gain value. So similar, the same procedure have to be followed for measurement of the temperature, and finally I get the value as 0.029. Okay, now guys, we compare the informations gain for my all 4 attributes. Okay, so what is the value getting for the temperature? It is 0.029, and for wind condition 0.048, and next Humidity condition 0.152 and outlook condition 0.247. 0.247. So we compare all the information gains of my different attributes. After comparison, yes, these particular outlook attributes information gain is high. So for that, I treat this as my root. Okay, so for that, yes, now I note down the outlook as my root node. Is it clear? So we have to find out all attributes gain. Okay, which attribute has the highest gain? That attribute can be represented or treated as a root node. Okay, so after getting this root node, yes, we considered this as the main condition. Okay, in that outlook, how many instances we have? Yes, three values: sunny, overcast, and rain condition. Okay, so for overcast condition, yes, I coming to the outlook and I clearly concentrate on this outlook. So sunny, overcast, and rain condition. So if you observed sunny, yes, 5 are there. Out of 5, 2 S and 3 no's are there. But coming to the overcast, only we have the 4S condition. Yes, we have the 4 overcast instances, and for all 4, yes, it is yes. So for that, my representation is from outlook to overcast, yes, branch, and again I said this as the S condition. Okay, here what are the days of 4 days? Okay, from the data set I just represent these days: d3, d7, d12, and d13, and here 4 are positive and 0 are negative. That means 4 are S condition and 0 are the no condition. So here out of all 4 I get the S. So for that I directly note down it as the S. Next, coming to the sunny condition, yes, 2 are positive and 3 are negative. So for that I have to follow the same procedure for this condition. Yes, coming to the rain, 3 are positive and 2 are negative. So for that again I have to follow the same procedure for this condition. So okay, so now I considered, yes, sunny as the subcondition. So now from the sunny onwards, okay, I have to find out remaining all the things. Yes, sunny and humidity, sunny and temperature, sunny and wind. So guys, I just considered outlook as sunny. In that condition, yes, sunny temperature, sunny humidity, and sunny wind. Okay, so yes, I can find out all the information gains for these attributes instances by following the same procedure. Okay, so it somewhat it takes the huge time. So for that I try to follow the some general analysis procedure, and also I have to apply the same procedure for rain condition also. Okay, rain humidity, rain temperature, and rain wind condition. So yes, by analyzing the data set, I just move the some without a calculation part. Yes, here coming to the temperature, hot, mild, cool, 3 values are there, 3 instances are there. Okay, so for that I didn't use this temperature. And coming to the humidity, yes, high and normal, only 2 instances are there. If you clearly observe, humidity is high, yes, Platonus is no, and humidity is normal, yes, Platonus is yes. Okay, somewhat humidity is to be considered to simplify the sunny condition. Next, coming to the wind condition, weak condition no, strong condition no. So it is also not suitable to classify the sunny. So now sunny can be classified with the humidity. Okay, guys, yes. So for the root condition outlook, yes, coming to the sunny, yes, I mentioned all these days. So sunny, humidity equals to high, what is my game? Yes, no condition. So humidity equals to normal, yes, Platonus is yes. So my leaf is to be yes, I have to note down. So guys, yes, sunny. After sunny, I considered as the branch node as humidity. As for this humidity, it is high. Yes, my leaf is to be no. Whenever humidity is normal, my leaf is to be known as S. Okay, so by the analysis process, we can easily identify this in spite of measuring all the calculations. Okay, next coming to the rain. Coming to the rain condition, yes, temperature mild and cool. Yes, for mild it is yes we are getting, and cool also we get the S. So temperature is not suitable to classify the rain. And coming to the humidity, yes, high is also yes, and normal is also yes. Yes, humidity is also not suitable to classify the humidity. Okay, sorry, classify the rain. And next coming to the wind. Wind condition, yes, weak and weak. Yes, whenever wind is equals to weak, yes, Platonus is yes we got. And whenever it is strong, Platonus is no. So guys, yes, simply we can mention this as wind equals to weak, all says the yes. So I mentioned the leaf as S, and wind equals to strong, my leaf is no. So for that, yes, after rain, yes, I mentioned the wind condition, and wind, in that wind is strong, yes, my leaf is mentioned as no. And wind equals to weak, yes, I mentioned the leaf as S. Is it clear now? So in spite of measuring all these calculations, by simply analyzing the data set or the given data values, we can easily find out the node and the subnode and the leaves through their branches. Okay, so now yes, I try to note down the values as simply outlook equals to overcast. Yes, this is directly we got, because out of all four we can get the S condition. So outlook equals to overcast equals to Platonus. And next second condition, outlook equals to sunny and humidity. Sunny and humidity. And what is the value for humidity we considered? Yes, humidity normal. Yes, humidity equals to high condition. Yes, play is no. Humidity equals to normal, play equals to yes. And next rain condition, yes, outlook equals to rain and wind. What is the wind value? Wind equals to weak, then only play S. Whenever wind equals to strong, play game equals to no. So wind equals to strong, leaf value as no. Okay, so like this we can easily represent the hypothesis. Okay, so guys, this is about the decision tree learning by the hypothesis search. Okay, now next class we will go through the decision tree algorithm. Okay, I hope you all understand this topic. Okay, see you again. Bye. Thank you.